Hi. Oh, yeah. So let me share the screen a little bit. Okay. Okay. Can you guys see the presentation?
Yeah, we can see it perfectly.
Okay. Yeah. So hi again, everyone. I'm Sarawit from Band Protocol. So I'm here with my colleague Paul.
Hey
Paul.
guys.
Yeah.
Yep, yep, yep.
Yeah. So today I'll be presenting about our tool for engineering and deploying bonding curve for the Ethereum blockchain. So yeah, let's just get started. So a little bit about myself. I'm Sarawit. Again, I'm a CTO at Band Protocol. We are building kind of like a toolkit for people to build decentralized curation communities. And I graduated from MIT a while ago. And previously, I worked as a core developer at Hudson River Trading, which is a high frequency trading firm, trading a bunch of stuff, including Bitcoin as well. And before that, I was an engineer in the Bay Area. So a little bit about the agenda. So first I will talk about a band protocol overview. So a little bit about what we do. And then we talk about the pain points when we work with bonding curve. And next we'll talk about the solution that we have to that pain points, and at the end we will finish it with the demo of our product and that will help you create like curation communities easily. So that's the agenda of this presentation. So first, let me start by introducing Band Protocol a little bit. So that's the website. So basically, at Band Protocol, we are building like a toolkit for regular developers, so they can add token economics to their applications. So the point is that each community will have its own token bonded with bonding curve, its own ERC20 token to be specific. So I think we all are familiar with the benefit of bonding curve, right? And and the tokens inside communities can be used to incentivize good behaviors and punish bad behaviors inside communities, such as by using TCR or rewards. The point is that developers do not need to have a deep understanding of blockchain in order to start having this kind of like curation communities running inside their application, because band protocol will try to abstract it out. We have like web apps, so they can start creating tokens from there, and then we have familiar like JavaScript library or REST API, so they can connect to their community without needing to go through the mess of Web3 events, Ethereum events, or stuff like that. So that's the idea of band protocol. And as you can see, bonding curve is such an important part of band protocol as a whole. So when we start building band protocol, we encounter a bunch of pain points. To name a few, the first is that uh, although bonding curve concept is not difficult to understand, is quite challenging to visualize how bonding curve will change, how the price, how the market cap, how the collateral will change as the supply of the token grows, right? So we need some tool to help people visualize how changing parameters will affect the bonding curve. I think during some of the previous calls, there's a tool called Bonding Curve Playground that help with this. So I want to, shout out for them. And the second pain point that we have is that right now with the existing bonding curve implementation, like in Bandcore, for example, although you can configure some of the parameters like the reserve ratio, the type of curve is quite limited. You get limit to that kind of polynomial curve. If you want to do something else, you need to kind of like fork the contract and rewrite some of the thing inside the contract. Or projects like Convergence, they have a way to configure different bonding curves, different types of bonding curve, but they implement each bonding curve for each of the type. Like they have a contract for linear curve, a contract for polynomial curve, contract for square root curve. Although that is nice, it won't scale well, right? If you have if you want to experiment with more kinds of bonding curves, you need to write more contract, and it's hard to get the contract right. And also it's expensive to do audit to all the contracts. So it's clear that we want some way so that you can write the contract once, and then different kinds of bonding curve can be just deployed from that contract directly. And the last point is that if we want the bonding curve to be adopted from the wider audience, we want a simple way for people to start creating tokens and start experimenting with a bonding curve, preferably as like a web interface, so they can just start building right away without needing to understand, writing Solidity and stuff like that. So that's the pain points that we want to solve when we start building band protocol. So we come up with the solution. Our solution consists of two parts. The first part is like a factory smart contract, so that when people want to build curation communities, they can just like shoot a transaction to this contract, and this contract will spin up like an ERC20 token contract with the bonding curve contract attached to it. So you can just deploy a new community just by sending one transaction. And the way we encode the equation is in an article that I wrote that we published last month. And we'll go over the rough overview of it in this presentation too. So that's the way we can easily deploy bonding curve contract. And the second thing that we provide is the tool for developers to kind of like visualize and deploy token from their web browser. So basically, you can just like choose the curve and then config parameters and then hit the button, and that will just deploy smart contract to the blockchain directly. And we will demo that too at the end of the presentation. Okay, so that's the main idea. So the next, I will show the technical detail of how we encode the bonding curve to be kind of like a transaction that you just send to the blockchain, and the blockchain will deploy the bonding curve for you. So there are 5 steps. The first step is you figure out the curve, what kind of curve that you want to deploy to the blockchain. And the second is you formalize the curve into an equation. After that, you reconstruct that equation in the form of the tree so that you can kind of explain the abstract equation in a more concrete format. And next, you turn that tree into a wire format, something that you can encode as a transaction to the blockchain. And at the end, you just hit the deploy button, and then that will deploy the bonding curve to the Ethereum blockchain. So this is kind of like the rough overview, and then I will go to each of the points in just a moment. So the first step is to figure out the curve that you want. So let's just assume that we want this kind of price curve on the left. Basically, we want the price to be constant for the first 100 tokens. And then after that, the price will go up linearly. So this is kind of like you want to sell token at fixed price to your friends. And then after that, you want the market to discover the price using bonding curve mechanics. So we cannot use the price curve directly to deploy to the blockchain, because it will be hard to compute the money that you need to pay to buy token. Instead, we use the collateral curve, which is essentially the integral of the price curve. So you can see that in the first 100 tokens, the collateral goes up linearly because the price is constant. And then after that, it goes up in terms of like polynomial. So having this collateral curve, if you want to buy token to ship the supply from A to B, you just find the collateral at point B, subtracted by collateral at point A, and then you get the price of the purchase. Does make sense? If you guys have a question, you can interrupt, or we can have question later, I guess.
Cool, thanks so much. We actually, if you guys want to ask any questions, you're also welcome to drop them into the chat tool, and we can reach them at the end of your presentation. Or would you prefer if you ask throughout?
I go to this like too quickly, so please call me and slow me down if I talk too quickly. But
I think it's going well. It's going great.
Okay, Okay, so now we have the collateral curve, right? It's kind of like a linear at the start and then go polynomial. So we need some way to capture this concept into like abstract equation. And here is the equation. The equation is that the collateral is x if x is less than 100. Otherwise, it becomes x plus the polynomial part, which is the part that exceeds 100 square. So this is the equation that we want it to go to the blockchain. After that, we construct a tree of this expression. This is the same way as the way compiler does kind of like encode the code that you write when you write kind of like the math expression. So it goes into a tree structure. The first node is an if statement, and then the if has the left part as the condition, x less than equal to 100. And if that is right, then it goes to the middle one, the x part. Otherwise, it goes to the right one, which is kind of like x plus x minus 100 square. So this is kind of like more concrete view of the bonding curve that you want. However, this is not concrete enough because the blockchain doesn't know about if or less than equals to or plus or stuff like that. So we need to go a little bit lower level. So to do that, we define like a static mapping in our smart contract that maps each of the operation into a number. For example, an if statement is number 18 or 14 is the less than equals to. So basically we transform that tree into another tree with actual number inside it. Note that the variable becomes like number 1 and constant like 100 becomes 0 and 100. This is to make sure that the blockchain is not confusing number 100 with the opcode of 100, if that makes sense. So here we get the wire format. And lastly, we just do a tree traversal. We do this kind of like pre-order traversal to transform this tree into a list of numbers. And there we go. This list of numbers encode the whole, like bonding curve equation that we want. So the last step is just to send it to the blockchain. So we have a function called create new community that takes a bunch of parameters, including the name, the symbol, and other stuff like voting, because in our communities, you can conduct a vote and do it the same way as Aragon do stuff. And the last parameter is the expression array. And when you send this to the blockchain, it will kind of like unfold this array and construct the bonding curve. And you got a new community with that bonding curve. So that's the end of the kind of like hardcore technical part, and I'll go to the demo later. Right now, sorry. So yeah, let's jump to the demo. I need to. Can you see the screen, or do I need to share one?
Demo time, or no, I see demo time.
Okay. Yeah. How do we do this? Okay, can you see the screen?
Yeah.
Okay, so this is like an internal version of Band Protocol, like web portal. So essentially in this portal, we have like a list of all communities that have been created on Band Protocol. And we will explore each community in a little bit, but at first, let me go into the create community, right? So here you can create a new community inside Band Protocol that has its own token bonded with bonding curve and stuff like that. So at first you need to upload the logo and the banner of communities. Let me just do. So all this information will be uploaded to IPFS and then encoded and go to the blockchain. So nothing is stored on a centralized server. And then when you press next, you go into the curve selection portal. So here we have a three kind of curves that we predefine, and people can go here and then adjust the initial price and the rate of increase, for example, and then you can see the price and then the collateral curve. as well as the price equation of the bonding curve. And you can go into polynomial and do the same thing, or sigmoid. And for sigmoid, there are three parameters that you can configure: the rate of increase, which show like how steep the price equation is, and turning point supply, where you can move around the point where the price starts moving, and obviously the maximum price. And below you can see the price equation that gets generated, and when you press next, let me set initial price to 20 and 50. As you can see, the price equation, it goes polynomial here, and then 20 as the initial price. When I press next, I go to the last portal, which is setting up the parameters. We won't go into the detail, but essentially this is the way you can configure how to change the parameter. And this is the bonding curve parameter. The liquidity fee is, the spread between buy and sell price, and the inflation rate is the rate where the curve start minting tokens and to reward people. And when you click submit, it will wait for a little bit to do some computation, and at the end it will emit, like it will send a transaction to that contract that's deploy community for you. Okay, let me just edit the gas price and then confirm. So this is all on the Rinkeby testnet. Okay, so while we are waiting for that transaction, we can go to some existing community. For example, the Doge Lover. Here you can see stuff that you see in Etherscan, pretty much, the community information. All this is from the blockchain and the existing stats, right? And there are two graphs here, the price. So this will change every time people, wait, what? Okay. This will change every time when people buy or sell from the bonding curve. So it will track the price according to the bonding curve. And the right one is the graph of the price when the supply changes. So this is the current supply, and you can see that when supply changes, the price will increase by bonding curve. And lastly, we have the rich list and transfer history, order history, something similar to Etherscan, I assume. So now the commodity that we deploy should appear on the bottom. Let's see. I think it's this one, is the hello world description. So if you go into here, you see that the initial price is 20, and you can start buying tokens from this portal. So if you put price this, it will generate the price for you. You press buy token, and it will send a transaction to buy tokens. Oh, so we have this kind of like transaction history, and when the transaction is confirmed, it will change to confirm. Yeah, and now if we refresh the page, hopefully on the left side, it will show that I have some of the tokens that we created. It should, because the supply is now 10K. So it should be me who bought the token. Okay, awesome. So that's the end of the demo. I'm happy to take any question.
Wow, that was a really, really cool demo. It's cool to see how far you guys have come with this. How many people are there working in your team?
So right now our team is a team of 7 full-time engineers that we work together. Yeah.
Okay, incredible. Does anyone have any questions for Band Protocol team?
Go ahead. We all started speaking at the same time. I was just gonna ask if you guys could put contact information so we could like discuss further, because I'd totally love to chat about this in longer form offline of the call. So if you have anywhere like a Telegram or something, that'd be really great.
Yeah, we have a Telegram channel, Band Protocol Telegram
Nice.
channel.
Perfect.
I
Please
think
can you drop it
on
into
our
the chat? We can also, I can send it out to everyone as well, or add it to the document afterwards.
Cool.
One of the questions on the chat is how would issues like front running be addressed?
Oh yeah, that is a great question. So right now that's a big problem, of course, and we don't have like a real way to deal with it apart from the ways that communities already know it, right? Like the way Bancor do the price limit and the maximum gas price. We are also experimenting with the batch body curve as well. So that's how we are dealing with front running at the moment.
And just want to add a little bit to that. We think using price spread is another option too. So if we impose, let's say 0.5% on every transaction, it would be tougher to do the attack like this.
Yeah, so as you can see, when you deploy communities, there's parameters called liquidity fee. That is essentially the price spread. So that make the price of buying token and selling token a little bit different, and the difference of that goes to the community creator.
Cool. What tech are you using on the front end stack? Just out of interest sake.
What the front end stack?
The front end that was built was just a very smooth demo. So yeah, just wanted to find out what sort of tech stack you guys built that with.
Yeah. So the stack, the front end is essentially a React with Redux at the store of data. So I think it's pretty standard in this age. And the back end we have like kind of like a server that subscribe to Ethereum and provide kind of like a GraphQL query endpoint. So the front end can kind of like query any information about any band communities that it wants.
Okay, that's awesome. And then transaction signing obviously happening front end?
Yeah, that is correct.
Fantastic. That's awesome. No, look, very impressive demo.
Thanks.
Brilliant. So if you guys have any other questions, you're also welcome to drop them in the chat, and we can now. Oh wait, can you also just add your link to the GitHub repo if there's one? If there are any other questions as well, you can drop them in the chat, and we can openly address them in the open discussion section at the end after the next presentation. But yeah, thank you so much, guys. That was an absolutely brilliant presentation. And the next speakers for this evening are Jeffrey Emmett and Abby. So over to you guys.
Hey everybody, just make sure I can share this okay. Is that working all right?
Yeah, it's working fine.
Okay.
Cool. Also, so just to give some people some background as well, last month as well, Jeff and Abby presented on augmented bonding curves and also a little bit about the commons, and I think they're diving a little bit deeper in today.
Okay, is that coming through all right?
Yeah, I was just going to say, Jeff, as an overview for what we're going to talk about, is that Jeff's going to kind of walk through some deeper narrative into what we're doing with the common stack. And then I can give a quick update on some of the augmented bonding curve stuff that we've been working on.
Yeah, so I guess the last talk, we got really deep into the technical components of how one aspect of our system worked. And I just wanted to give kind of a more broad overview of how the whole system will come together. And let me just pull the chat up here so I can see it. Okay, perfect. So the project that we are working on is called the Common Stack, and we are looking to build a scalable infrastructure for community collaboration. So what is a commons? This is the first question. A Elinor Ostrom, for anybody who is familiar with her, she has done a lot of research on cooperative alternatives beyond markets and states. So in other words, she looked at community resources governed by communities themselves and how they can achieve sustainability in use of those resources in common goods. So commons basically take the best of both worlds between a competitive market and a compulsory state. So we can think of them as digital cooperatives, which are owned and governed by users for collective benefit, and that is around a specified goal as well. So I mean, a common example is the tragedy of the commons is a common field for grazing, and maintaining enough resources within that field to be sustainable for all people who use that. There are a couple of articles here. I can share this afterwards. A few people who are bringing Ostrom's learnings into the blockchain space, and some really good resources there. So if we just look quickly at some of the pros and cons of various types of human collaboration. So we have markets. They're very efficient. They have natural selection through competition. They're decentralized, they're non-hierarchical. There's no one in charge of a market. However, the downsides of a market is it's ruled by money and profit. It falls prey to the tragedy of the commons, where, you know, if you have 10 farmers around a field, each farmer benefits greatly by adding a second cow at the detriment, only a small detriment to everybody else. So when you maximize for one-dimensional metric like profit or personal gain, you lose out ultimately, because everyone will take just a slight bit more, and you have collapsing resources, collapsing fisheries, etc. States, on the other hand, are able to implement these overarching incentives like environmental protection. They add costs for polluting, they add costs for going over your fair share, and that protects against the tragedy of the commons. However, governments are often inefficient. They don't have the competitiveness of markets. They're incentivized to maintain budgets rather than reduce budgets. They're also centralized, and they fall prey to peak hierarchy. So you have top-down decision-making and not necessarily the right solutions on the ground. So when we combine these two, we can see that commons can be market efficient. They can include those community decided incentives, and they're also decentralized and non-hierarchical. But the cons are they're very difficult to set up because there are so many stakeholders involved. They're also very difficult to scale, and we feel that they need digital infrastructure. So there are lots of great examples of successful community commons around the world, and we are basically looking to provide a digital infrastructure to allow any community to use those principles to have the best of both of these worlds and build greater collaboration frameworks. So Elinor Ostrom identified 8 commons principles. We don't have to go through all of them, but if you are interested, you can definitely take a look at these. This is basically when she analyzed all of these communities around the world, these were kind of 8 core principles that she realized existed in each of these communities. And a lot of these can be encoded in smart contracts and in the various components of the common stack to make sure that we can provide these principles to any commons that we decide to build. So what are we trying to accomplish with the common stack? We are aiming to solve the tragedy of the commons and the free rider problem through properly designed community incentive structures. So when we combine the efficiency of markets with effective boundary setting that governments aim for, we can potentially build new models of collaboration that can supersede anything that we've come up with so far. And how do we do this? I mean, big words here. I don't expect anybody to follow, and I didn't a lot of the time either, but stochastic optimal controllers are basically what we are building. And this is through the use of AI and machine learning and human controlled is the most important part of this system. But yeah, we can start to collaborate on new levels with these tools. So our first goal is to create a full reference implementation of all the components required to build this digital commons infrastructure. And this is including mathematical formalization and simulation. So we're not just building this off a narrative. We are wanting to do this properly as best we can. And goal number 2, we want to coalesce a community of token engineering and DAO and curation market experts to launch various experimental commons efforts from this infrastructure. And what problems does this solve? So, I mean, this is the free rider problem, and the tragedy of the commons in some way underlies most of our big coordination problems as a species. So this could be used for anything from incentivizing open source initiatives, rewarding open source developers for important contributions to the tech stacks that most of our global infrastructure runs on. We could create citizen-led subsidies for emergent self-organizing solutions. We could act on climate change without waiting for top-down government initiatives like subsidies on solar panels, which may not be effective for every community. We have, you know, kind of peak hierarchy issues there. We could incentivize cleaning up trash around the planet. And creating new collaboration frameworks for global endeavors like space exploration or new drug development, which I believe Molecule is working on. Really interesting stuff there. So our initial common stack, I mean, we're starting out fairly basic, and we're building this module by module to be more robust. But essentially, you know, it starts with 4 components. We can raise funding through our augmented bonding curves, which Abby will give us a bit of a deep dive in after this. Then we have to make decisions on how that funding is allocated. And then the capital flows out to the projects to be worked on, and then measuring impact of those projects. And this kind of forms the basis of the common stack that we can build off of. And we have a long roadmap with many different components, and they're definitely by no means totally fleshed out. I think there's a lot of work that needs to go into this, but you know, we've identified a few of these components so far: continuous funding mechanism, community decision making, which we're calling momentum voting, transparent and accountable funding allocation, which we're using the Giveth donation app, a measurement system to determine the value of labor provided in the commons, which SourceCred has been working on, community identity system, which would likely be IDEN3. We're going to work on some expertise-weighted governance systems, dispute resolution systems, and of course, there are many more aspects and components to this to be built out. And essentially, we are looking to collaborate with all the experts in the community who can assist in building these systems, in ideating on these systems, in you know, double checking the math, double checking all of these components so that we can build this sustainable infrastructure together. Some of the design principles we're looking to use: we want to design as nature. There seem to be stable ratios that exist in nature that we want to make sure that we are hitting on. And when you design, you know, scalable systems, we want to avoid all of the potential problems in that. So we're looking to stay to the biomimetic design. We're also designing from mathematical first principles. So we are defining conservation laws through what we're calling the token physics of these systems, and then utilizing the latest practices in token engineering to design off of those token physics, and using iterative simulations and building upon our models once we find any issues as we go through this experimental process, using zero-knowledge proofs were required, and bleeding edge technology in the blockchain space. So what are we looking for in the Common Stack? Right now, we're looking for people, talented developers, storytellers, organizers, change makers, idea people. And this is a really big project, and I think it can assist almost every other project in the space. And we are basically looking to build that community. We have 5 teams entered into the Odyssey Hackathon in Amsterdam in the middle of this month. If there's anyone interested, we're basically hacking on a few different components of the Common Stack, and we would love any interest or shoot us a message if you are interested in that. And we're also looking for funding to continue the development of these ideas. So contributors to the Common Stack will help determine the direction and progress of the initiative once we have these governance modules set up. Contributors are also whitelisted for participation in upcoming Commons prototypes. So our first thought for a prototype Commons is to create a token engineering Commons so that we can build out the practices of token engineering using the mechanisms that we're building with token engineering. So it's kind of a inception meta level collaborating around collaboration. And we've been in contact with most of the leading token engineering researchers worldwide. And everyone is very excited about this. And we'd love to have everyone who's interested join us. And this is some contact information. If anybody has any further questions, would be happy to discuss further. And I think that is the last, that's the last slide.
Amazing. Thank you so much, Jeff and Avi. Great presentation, very exciting. I think that there were a few questions that came through in the chat. I think some people asking for references, asking about tools, but I see Abby answered that already. A question is it for free? Is this the hackathon?
The CAD tool. Yeah, so they're launching, the CAD tool is basically exactly that formalization and simulation software that Michael Zargam and the Block Science team have been developing to do exactly what we're trying to do, which is actually simulate and see if these things and these primitives work in real life. So the CAD tool, they're actually launching a beta program right now. So I would connect with, I can put in Jonathan Gabler's information. He's kind of leading the charge on the CAD launch into the ecosystem. So I'll include his information and anything else I can find on the CAD stuff.
Thanks, Abby. Questions from anyone else? Paul says, incredibly ambitious, love the full stack approach. Do you have a date for your first prototype kit?
So not a date. I think we'll have a better idea coming out of the Odyssey Hackathon, because the Odyssey Hackathon's goals is that we have 4 teams building 4 of those modules that are in the Common Stack. So the one that is most on track to being implemented is the augmented bonding curve. As I said last month, we have a bunch of research going into it, and coming out this week, ideally, will be the deeper technical dive into the augmenting bonding curve module that includes the simulations that we've put together of the curve, of return rates, of everything that has to do with that system. So I think that we'll have better idea of dates and roadmap coming out of this hackathon, and I'm really hoping, and we're all hoping, that this hackathon will also be kind of like the launch of this larger community of people contributing to the Common Stack. And hopefully we'll see a lot more work going into building out these prototypes and modules. So, and we're also looking for a couple more hackathon members. So specifically on the augmented bonding curve team, if anybody is interested, we're really looking for like full stack devs and coming together. Maybe someone from the band protocol team. You guys can come and out with us in Amsterdam, because that would be so awesome. So yeah, definitely we'll be in touch. Hopefully next month we'll have better timelines and roadmaps for everybody.
Okay, brilliant. Yeah, I think I'll throw out a call as well from our side to call for people to come and join your teams and participate in the hackathon. Cool. Does anyone have any other questions?
Yeah, this is just one more question. This is Spencer. I'm curious, beyond technical roles, what other kinds of collaborators or roles are you interested in filling out? Or are you looking for?
Yeah, totally. I think that, I mean, the biggest thing is kind of the whole narrative and storytelling. Beyond just being able to tell a story, it's also being able to back up the core assumptions that we're making about the political, social, and economic implications of these community funding and governing models. So, and I think that anybody who has like product experience, and managing the creation of these prototypes is really great, but also people who have that more deeper academic perspective on the implications of what these reference implementations will be able to that create, right? So like actually how this fits into our current economy, how does this fit into politics, how does this fit legal structures and stuff like that. Like the full stack approach is like a technical full stack approach, but it's also like a real world full stack approach. So I would say that we're very open to having conversations and trying to get as many people contributing. So I just posted my personal Telegram, and Jeff, you should post your Telegram too in the chat. We don't have a group chat for the Commons yet. Again, we want that to come after Odyssey, but feel free to reach out personally and we can have like a more in-depth discussion about it.
Great, thanks.
So the presentations actually ended a little bit earlier today than we usually do. So if anyone has anything that they'd like to maybe bring up, or any open floor discussions, any projects anyone's working on, any general questions, you're welcome to bring them up. And then our presenters and speakers and any other experts on the call are welcome to jump in and try and answer them, if there is anything.
I could share my screen and show the equations behind the augmented bonding curve if anybody wants to see them. I mean, why not, right? Is that cool?
Sure, yeah.
Okay,
I'll
cool.
buy it.
You don't mind? Okay, great. Everybody else is like, oh man, really? Here, I will, it'll just be briefly because I'm also have a paper, an article coming out about this. Okay.
Well, Abby, you got a lot of +1s here. Everyone's keen.
Oh, great. I don't even know where to see +1, so that's great. Okay, so this is basically just like the HackMD that I have in an article, which will be coming out hopefully very soon. So stay tuned. But so these are kind of like the mathematics that we're working with the augmented bonding curve. So as just like a refresher, the augmented bonding curve is really cool because it's basically a token minting scheme that's attached to a floating pool of capital in a funding pool that can be governed upon to allocate funding to people contributing labor to the commons. And then the second mechanism that's really interesting about the augmented bonding curve is the vesting period. So there's like 2 phases of the curve. And again, I talked about this last month, so I won't get too deep into it. But again, happy to discuss. But initial token buyers who hatch the curve, we call them hatchers. So initial contributors to the curve who are buying in, their tokens are locked. So they can't just unlock them and spend them and burn them within the curve like you would kind of in a speculative situation or like a Ponzi scheme, right? They vest, and they vest in accordance to how the funds in that floating pool of capital, the funding pool, are allocated. So you have this like really cool feedback loop that's flowing entirely through the system. And so the equations are really great because they kind of describe that, right? And so the initial hatch sale is all, the key thing coming out of these equations is that the return factor, so how much money, the multiple of the initial hatcher's return, is not dependent off of the initial amount of money or how much money you raise. It's all a derivative of the power function invariant, which is basically like the shape of the curve. And we're able to derive a post-hatch price. This is the price of the curve once it reaches that end of the first hatch phase, and when it opens up to the rest of the comments. So this is a really cool concept because it proves that this is a really robust system. And so we have like some pretty graphs that show at different power functions, so basically at different exponents, at different degrees of freedom, what the return factor would be. And so this will be in the article and kind of dive in deeper. But so under ideal conditions, you know, we are able to prove that this system actually has some robustness and scalability to it. And then the second thing to point out is that these are the mechanism equations. So basically, like what happens when you deposit money to mint tokens within the curve, and what happens when you burn tokens to withdraw money within the curve. And the thing that this is all based off of Michael Zargham's work at Block Science, and he's designed them to basically be energy conservation equations that all balance out. And so basically, this system, and what I wanted to get across by talking about it right now, very much so has created its own like type of energy conservation in the state space that is the augmented bonding curve system. And this goes back to the key theory behind the creation of the augmented bonding curve is kind of like remodeling like what a biomimetic natural signaling system can be in accordance to like a bonding curve. So that was a lot of information, but maybe it's just to get you excited about the article that is coming out. And I'll be sure to send that to Devin and have her send that out to everybody here so you can kind of actually make sense of what I just threw at you guys.
Yeah, and I think to build on that a little bit, we have, you know, when we're designing circuits or we're designing bridges or buildings, we're working off conservation laws like V equals IR, E equals MC squared. You know, there are all sorts of physical conservation principles in nature. And when we design an economy, which we've never really done before, we've decided it's important that the conservation principles, which such as, you know, when you're bonding or burning from the curve, you have to have conservation between these tokens. So you can define the first principles of those, and then all of these other equations are derived off of those first principles. So not to say that it's right in the first go, but at least it is following these biomimetic design principles. And of course, with the iteration and simulation and testing that will be involved in the token engineering process, we're excited to see where this goes.
Very well said.
I'm also really excited to see it, and I'm also very excited for that article to come out so that I can.
I know. I feel like there's such high expectations, so hopefully we'll be able to, you know, reach those for you guys.
Definitely. Cool. Awesome. Thank you so much, Abby. I think that was great. And I also thank you so much to the Band Protocol team. You guys had an awesome demo. I think this was a pretty cool one. I'm actually happy to cut it. Well, it's like 4 minutes short now. So yeah, thank you all for joining.
Thanks.
If you guys do have any questions, if you'd like to chat afterwards, you're also welcome to drop a message. And I think there's a TCR chat somewhere on Telegram, or send me an email or anything that happens. If you do want to present at any future meetups as well, you can just drop me an email. And yeah, thanks so much, guys. I'll see you next time.
Thanks,
All right,
guys.
thanks, guys.
Thanks all.
Thanks, guys.